Fine. Okay. Yeah. Good afternoon, everyone. Once again. So, as you know, you are almost in the last day of your faculty program development. So, with respect to the title, it was told that initially I'll be speaking on documentation of research data, results, and research publication. Along with that, I have included few slides which compiles about research ethical practice as well as career advancement. Okay, as told, my name is Shankar Ji. I work as a UGC assistant professor at Department of Chemistry, Bangalore University. I would like to emphasize on this particular NAC. Recently, I mean, after Corona, it was we were in the process of getting this NAC accreditation, and I'm happy to share that we were accredited with A double plus grade. And during that time, almost 2 years before, during that time, Bangalore University was one such third university in the entire nation. We were recorded with a score of 3.75 out of 5. So in that way, let's start with this only. Like, how do we get such a kind of A double plus grade? It's all purely because of documentation. So we all know that most of the people who are present here are faculties, wherein documentation is a very key source for the NAC. Because there are some 7 criteria. If all the criteria are equally contributed towards the university or the college program, then only like NAC is going to accredit with a very good score, and then based on the score, you are going to get whether it is A, B, or A double plus. So by this, one thing we learn is documentation is very important, irrespective whether you are in research or teaching, non-teaching, or any kind of work professionally you are doing. Documentation becomes very prime. Okay. I hope you are able to see my second slide. Let me start with this documentation. This is a piece of newspaper wherein you might have seen, few of you people might have already seen. With respect to this documentation, it is still debatable. Some says this particular person addressed all this content in British Parliament in the year 2nd February 1835, and some says not. But overall, whatever it is mentioned in this documentation is 100% true. So what exactly this documentation says? So let's see, this person is called as Lord Macaulay. I'm little bit hesitant to call him as a Lord. Actually, his name is Thomas Macaulay, wherein this particular person has traveled entire India. It's like length and breadth. Maybe like we can take it as right from Kashmir to Kanyakumari, as well as from Gujarat to the northeastern part of the India, wherein he was not able to find even a single person who was a thief, who was a beggar, and India was a very rich content country with a high caliber people, and also having lot of very rich ancient education system, and the entire country as such were doing extremely good. They were doing progress, as well as they were at the prosperity to its peak. And also he thought the only way to rule these people is somehow break the backbone of this particular country, wherein break this very good education system and then introduce English media. And also he realized that few people have a very low self-esteem on their own education system, and also they give more importance to the English and other foreign language. So this is not only happening way back in 1835, even today. I mean, this is the same impact what we have. We always give more impact if something is happening from the Western country. So you can realize that way back in 18th century itself. So India was doing a lot of good things, and we had one of the best education system in entire world. Okay, so let's see how this education system or completely as a country was spread across. So we were very good at entertainment as well as advanced science. As you can see, entertainment, we are some of the pioneers to introduce some of the well-known games which is played even today. For example, we call it as Chaduranga, the chess, which not only entertains you, it also makes you think like how to move, and then hardcore your brain as well as your novel thoughts are required to play this game. And Pachisi, Ludo, the Snake and Ladder, which on those days called as Mokshapadam, and dice games. Not only in the game, also like we were very rich in performing arts like music, classical dance, and vibrant theatre plays, especially the plays from Kalidasa, wherein it used to convey a very strong thematic message to the society, wherein that was like a part of our education system, and storytelling, oral tradition, poetry, recitations. And even recently, there was a research conducted in Harvard wherein we had a tradition of passing this information from one generation to other generation through orally. It is like called as padabanda, wherein we recite something and then over a period of time it is stored in your long memory cell, and for the next generation you are going to teach that so that they pass on from one to the other one. So this is also kind of documentation wherein it is directly stored in our brain. Apart from that, we were extremely pioneers in some martial arts, archery, kabaddi, kho, and India is well known for their cultural diversity. And for example, like if you start in the beginning of the year, new year, so we have this festival called Sankranti or Pongal or Vishu across northern part of India. This clearly says that we are very very rich in culture as well as at the same time we are diverse. So moving on to the next advanced system, that is science. So Indians were very good at science, astronomy, metallurgy, medicine, as well as engineering and textile. We all know that this famous mathematician, or and also he is a very good astronomer. So Aryabhatta, who introduced the value of a decimal point and also the value of a pi, 3.14 and so on. So the concept of a zero was introduced by him. So before that, it was only the Roman numbers which was practiced and used across the globe. Imagine like you want to present something like six digit number or seven digit number. Following this Roman numeral system will become highly cumbersome. So for that reason also, like when this zero concept was introduced, this entire Romans were a little against this Indian numerical system. And also, as I told you, Aryabhatta was extremely pioneer in astronomy as well. He was the first person to state that Earth is Earth rotates as well as it is spherical in organization. And also, he was the first person to calculate the circumference of the Earth, which is known to be something around 24,000 miles. So, but on record, if we see, it is named after a Greek person called Eratosthenes. Eratosthenes, it's a Greek name, Eratosthenes, wherein he has exactly calculated and found to be 24,902 miles. So wherein this all this was happening somewhere in the 4th century before Common Era. So you see, like we had a lot of documented result in the form of a textbook and many other different source. But over a period of time, all this perished. So we'll see like how this happened and right now where exactly we stand. And also coming to the metallurgy, we all know the uniqueness of this Delhi iron pillar. So it is even now standing without any kind of rust on its surface. Because like recently it was taken, and then with the carbon dating technology, it was found that there was 1% of phosphorus was added along with the other alloy to make this kind of iron pillar. So all this we had in a very good documentation, but over a period of time, as I told you a little early, so it vanished or something else has happened. Nobody knows what exactly has happened. So because we don't have that kind of a documentation over a period of time, so either it was taken away or misused or stolen from India or completely destroyed. So we're going to see one by one. And also we were extremely pioneer in making this woods steel production and also making a template out of wax casting. And we all know that Indians were very good at advanced surgery, especially like plastic surgery, cataract one. So all this kind of information was stored in Sushruta Samhita. Even now, I'm not sure like whether this particular textbook, which has a very rich source on medicine, is available or not. And engineering, we do not have to tell. Once you visit a lot of temples, especially the South Indian one, the marvelous architecture is a classical example of a very pioneer engineers were available during that time. And also we were very good at water management and large residential university wherein it can be like replicated to the present one of IIT and other pioneer research institute across India. So one such was called as Nalanda University, which is located in Bihar right now. And also we were extremely good at cottons and dyeing those cottons, making different kinds of fabric, which was very comfortable to use. Even now we all feel like, even though we might have different kinds of other material, cotton is one such which is very comfortable and we can use for a long run. Okay. I hope still it was audible and you were able to see the slide. And right now I have moved on to my next slide. Okay. Because what will happen most of the time when it is online, one person is speaking, really don't know like whether the other end the people are receiving what he spoke. So being optimistic, I conclude that whatever I'm speaking and showing my slide, you people are able to understand. Okay. Yeah. Now you people might be wondering. I, yeah. Hello, can anyone help me? Like, you people are able to hear, or some crosstalk is going on? Okay. Yeah. I, I request one of the organizers to help me, like, in responding to my little question. I kindly request the organizer to help me. I mean, some kind of crosstalk is going on. I'm not able to do my presentation. Hello, am I audible? Okay. Thinking that I'm audible and you people are able to see my slides. So people might be wondering what exactly the outlook of this particular talk would be. So we are going to see the documentation process, the history part of it, how evolution, how the documentation, what exactly happened to this documentation right from Mughals period and moving on to the colonial regime. Further, how exactly India rebuilt this entire documentation process or the research and development program post independence, and currently where exactly we are in. So for this, we need to go back a little bit towards 4th century. So we all know some of the ancient university existed in India. So one such named as Takshashila University, which was the first known university for India. So while the exact date of establishment is still debatable, but somewhere it is believed to be like functioning somewhere in 5th century before Common Era. So this particular Takshashila Institute or the university was well known to give a higher education system not only for the Indians, for people across the globe. And presently it is located now in Pakistan, one of our neighboring country. And this particular university, Nalanda University, well known, the name is very often heard or compared the rich legacy of advanced technology to this particular university. A prominent Buddhist Mahavir in the ancient Magadha kingdom established this entire university flourished somewhere between 4th and earlier 12th century. So, especially this particular university was well known not only in a particular research arena, also like covered medicine, astronomy, mathematics, chemistry, arts, and culture. Basically, like this particular university was teaching entire people the art of living. So other two university to add on Vikramshila University as well as Vallabha University, which was established by King Dharampal in the 8th century, which is once again like situated in Bihar, another one in the Gujarat. So all this was happening somewhere between 4th century and earlier 12th or 13th century. The other two universities to add on Jagadala University as well as Otanapuri University. So both from 8th and 12th century respectively, wherein one of the universities is currently located in another neighboring country, Bangladesh. The other one, Otanapuri University, is in Bihar once again. Like so, what is the main role of this university, which was only like limited number of university was there across the globe during that particular time, wherein people traveled from different parts of the globe. For example, like people from ancient Egypt, Mesopotamia period, ancient China, Greece, as well as ancient Rome, and also few people from Persian Empire and Mesoamerican. Everyone traveled and stayed there at, especially at Nalanda University for a quite long time. They studied different subject and carried that rich education system and then started spreading in their own country. So this is the some kind of a story. Although like we don't have any kind of a concrete evidence to show or claim that, but once we were in that such a rich legacy and had a very rich glory, what happened to those glory? I mean, where do we lost all those things? It is like now we can correlate to vanishing archive. So over a period of time, right from 4th century till the 13th century, it was like we had a many people invaded, and not only they looted our wealth, but also during I mean, their time they completely destroyed, which is quite evident, and a few of things are already we have studied in our history. So it was like. The British who has entered India in the 14th century, like 1491, right from there till the 18th century or earlier, mid of 19th century. So they have looted as much as possible and then completely destroyed. It is not only that they have destroyed our education system and also made sure that this kind of rich education is not carried to the next generation, so that everything they take, because now you understand the importance of education. Education is one such thing wherein it can change the fate of entire country. So at the same time it doesn't happen overnight. It takes long years. You see, British has ruled in excess of 360 plus years, but still they were not content, and still left over with much more wealth and little bit of education system. But right from that zero, we are trying to come up strongly by following a very good documentation process and trying to develop R&D. Okay, so let's see, like how the ancient education system was there, right from Gurukul to the current one called Gigabytes, a journey through Indian education system. During especially during those times, Sanskrit was one of the well-known language spoken, and was also used for the communication, and like the way I speak English today, because we all got used to it right from our schooling days till our higher education. We have been taught in English. We have learnt English. So this is the one the way in those Gurukul period, people used to communicate in the Sanskrit language. So it was like ancient Gurukul, wherein it was having a holistic learning of Guru Shishya bond, and they were teaching a lot of Vedas, life skills, and also we had a very good documented procedure. But it was the same person, as I mentioned, this British, who had not only like destroyed as many as 7 lakh gurukuls across the nation, and a few of the gurus along with their families were burnt completely alive to such extent brutally. I mean, they are not only destroyed, including the documentation procedure. So later, there was an evolution of this medieval influence. Then religion-based practices started, madrasas emerged, and religion knowledge persisted. So then came this colonial transformation, where everything was replaced by English, and we had influence from the Western culture. So this was the same guy, Thomas Macaulay, who had changed the entire education system. Since post-independence period, we are trying to have a very good mass education. Our IIT establishments are one such system, wherein across the India right now some 29 IITs are placed, wherein they are giving a very rich higher education system, and then in some place they are doing very cutting edge technology research. And later we have been started focusing on the science, technology, engineering, and mathematics, and also including diverse subjects like arts, commerce, and so on. Currently we are in digital age. The online particularly this FDP program is happening because of this digital age and smart learning. Recently, just I think 3 years back, there was an introduction of NEP program, wherein like we were not able to implement that successfully, because you see, 3 years, 4 years is a very very small period. So once we can develop a very good education system across the globe, then we are going to regain the lost glory what the ancient Indian had. Fine. So now coming to the merits and demerits of this documentation, I hope still you people are listening, audible, and my slides are scrolling. Okay. The knowledge gap, the high price of undocumented projects. So, what are the demerits of undocumentation? So it is like, imagine you are here as a research scholar or as a faculty, you're performing some project, you got some data, but your ultimate target is to reach this particular
మేడం
point.
ఒక పాయింట్ ఏదైనా కీ పాయింట్ చెప్పండి ఈయన చెప్పిన దాంట్లో. ఫీడ్బ్యాక్ ఉందా? ఫీడ్బ్యాక్ ఉంది. రోజు ఏదో పిచ్చి పిచ్చి రాస్తున్నా. ద యూసేజ్ ఆఫ్ టూల్స్.
Yeah. This
Sir,
is
please continue. Yeah.
yeah, sir. I kindly request one of you just please respond, because like it's kind of one-way communication.
No. Your sound is clear, sir. Yes.
Fine, fine,
Yes.
fine. Okay.
Please.
The knowledge gaps, like what are the demerits, if you're not documenting your data or the research properly. So first thing is like your target is to reach from this point to publication. Now you see like you have a lot of data around because you have conducted and performed a lot of experiment. So if it is not properly documented, it will be a time consuming. It requires extraordinarily effort to organize them in a particular fashion, analyze and then start writing, and also risk of misinterpretation. So what exactly is this misinterpretation? If you're not recording, your data properly, and this can sometime, lead to inconclusive result. For example, I would like to precisely, tell one particular issue what happened in the field of liquid crystals. We all know, like currently we are using this display technology. So this is almost like 20 years before. This liquid crystal technology, whatever we are using, it all made out of a liquid crystalline material called as a pneumatic material, wherein it is having a uniaxial system. So what does uniaxial? That means it is having one axis. When a field is applied, they respond. So there is something called as a biaxial pneumatic phase, where this biaxial pneumatic means it is having two different axes. So that means whatever the efficiency we are getting from this uniaxial material, if it is replaced by this biaxial material, so we can get as many as 1,000 times faster than the existing one. So the power consumption will be almost nil, and the amount of birefringence, overall the efficiency is going to increase almost like 1,000 times. So that's the important or uniqueness of this biaxial material. So initially what happened with the result, whatever they got, they thought like the dumbbell shaped in the XRD profile, so is evidence for the pneumatic biaxial pneumatic phase. But later, over a period of interpretation, it turned out to be not exactly the spontaneous biaxial, it is something else. That's all, like because of like not documenting the results properly and then organizing and then analyzing, always this will lead to this kind of error, so which will convey wrong message to the readers. And also if it is not documented properly, the sensitivity of your data, the confidentiality of your data will be at risk. So being getting exposed, both like you might lose personally, also like the proprietary information of our research might be at stake. So why this kind of I mean undocumentation as a very strong influence? Even if it is not documented, like it will be forcing you to, the pressure will be forcing you to practice this unethical procedures and try to go for the data manipulation and go for the plagiarism. So what exactly is this? That means like you have some data, you don't know exactly where it is. At the same time, you have a peer pressure, like you need to publish before the end of a particular deadline. So all this kind of unethical practice, data manipulation, and then just copying and pasting and trying to publish as quickly as possible. All this will lead to this kind of problem. And also some of the very good documented data, for example, like high impact factor journal doesn't come for free. It is having a paid version, it is having a subscribed version in order to get those kind of data, wherein most of the time getting into such kind of journal itself is a mammoth task. It's highly challenging. You need to have a substantial evidence for your research claim. So in such cases, like people cannot access this kind of documented procedure, the research article, basically I'm trying to tell you. So it doesn't come that easy. Limited access is also another bottleneck for this documented procedure. And reproducibility challenge. So imagine like you have entered a lab, you have carried out some experiment, you got some result, you wrote something and then published. If the same experiment is repeated some other time, you are not able to reproduce it. So why this is happening? Because of poor documentation. So that means like in a systematic way you need to document and then reproduce, then only the chances of getting success are more. So as I told you, risk of being scooped. So that means like if you don't do your documentation, carry out your research and then publish, so it is like someone else will publish. So you all know that research is one such wherein this particular research field is at the riskiest profession. For example, the first one comes your defense, wherein before enemy kills, you need to kill the enemy. So before someone else publishes your result, you need to publish. If not, at least you are going to lose the novelty. So in that way, like you need to be extremely cautious. Now moving on further, so what are the merits of documentation? So as I told you, the demerits, it's quite opposite to that of the demerits, transparency and reproducibility. So if you systematically follow this, so then you can ensure that your research has been verified and it can be reproduced by any other person, not only your lab, some other lab, or even in a different country. And also your research data should be of honesty. You cannot try to manipulate and then cover up with something else. Data integrity and accountability, because it maintains authenticity and accuracy of your research. And also once you confirm all these things, then you can disseminate the knowledge to the wider community, because you are confirmed that whatever the research findings or the data you have, it has been confirmed unambiguously. Now it can be spread across a wider community. So that's how like most of the textbooks are made, right from the schooling days to the PU college, and then to the college, and then to the university. Most of the basics whatever we are teaching at the college or at the university level, it's all like originally started as a research sometime long back. And also once you follow this strict documentation procedure, you'll be recognized academically, so which will lead to a very good citation. So by getting a good citation on a timely basis and a regular interval, so one will approach for a good collaboration, and also you will be known professionally to a wider group. For example, I make in our research lab at Bangalore University, we make a liquid crystalline molecule. So for most of the time, whatever we make, it's all pure, and it can be reproduced. So for that reason, we have a few collaborators wherein like blindly they accept whatever the material we send, the compound we send, and further characterization they take place. That is the kind of a trust we built over a period of time. It all happens because of very good documentation and ethical practice what we follow. And also like by good documentation, you can generate IPR, intellectual property, right? You have something novel invention which is patented. If somebody wants to use, you will not only be recognized, and also you can generate some kind of a revenue, which is really a good part of research. And also like imagine like you got some fund for your research. The research funding agency will have its own standard, and it will have its own protocol. One needs to follow strictly and meticulously follow the terms and condition in order to get subsequent release in the second, third, and so on. So and also this will facilitate future research. As I told you, sometimes with all this experimental, there are certain kind of a research group where they'll sit and try to generate new hypothesis, empirical formula, wherein that or even the statistical data, wherein that can be used to generate some new technology or invention, or it might lead to a discovery also. So all this kind of very good documentation is going to help in order to generate some kind of technology wherein we are going to use. So I'm going to discuss more about the case study, one or two case study precisely, and then see how exactly we use all these parameters in order to get a good result. So the main objective, what are the main objective of this documentation and the publication in research life cycle? So the first thing is like it is going to enhance the transparency and reproducibility, as I told you. So Vogel is one such textbook. I'm not sure like if some of you are from chemistry background. Vogel is one such a practical textbook wherein most of the lab, they refer to that in order to conduct a simple experiment for the chemistry student. So this particular book was designed in such a way that it works across all terrains, like not only in a country like India, even in a cold country, even in Middle East, across the globe, because this was repeated in number of times, and it was documented and then downsized to a workable procedure, and then it is text. So this I think originated from country Germany, wherein people start blindly using this Vogel textbook for any kind of a practical experiments for PU college or even the degree or even at university level. And also, as I told you, by following this documentation, it will establish credibility. So, which will not only demonstrate the professionalism and also academic integrity, and also it will strengthen the reliability of the published work. For example, if you are strictly following all these things over a period of time, if you are publishing a good research article, So there are certain people like who will recognize you and then always like rely any research article coming from a particular lab. It's highly good, and then one can reproduce, and then they can rely on those results, and then from there they can carry out further reaction. And also like the dissemination, how the results to the next generation is also equally important. As I told you, research, there are different types of research data. So we'll see like few of them. For example, like experimental data. So the data originating from the lab or field experiments. For example, from the research lab, we generate, especially in the chemistry or even in the physics or any kind of other research lab. So there will be a lot of spectroscopic data, the NMR, the CHN, the C13, HPLC, the chromatography. All those are like a kind of generated data, which we can call it as a data visualization. So those documents are very very important in order to claim any kind of results. So imagine like you have conducted some NMR, after 3 months or after 6 months you are going to publish. If that NMR is not solved and preserved properly, so it will be like you'll be in a confusion whether I have really made those compound, and then now I'm trying to publish this without any evidence. So always like documentation becomes very very important, especially in research. Observational research captured without any manipulation. So that means what, a survey response or climatic change. For example, recently there was a survey going on in one of our state, Bihar, where people used to go and then take a census, like try to find out the number of people living in that particular region. So if the data are not collected as it is and then trying to manipulate, it's going to give a false data. So whatever the output we get from this particular state, it's going to be like completely wrong. It's not exactly the same what is existing there. So that kind of manipulation should be avoided. Whatever it is there, it should be captured as it is. And also nowadays, like you make any kind of experimental data, people ask for computational data. So these are generated through different kinds of studies like molecular dynamic study, DFT calculation, wherein this becomes very very prime. So you need to arrange them in a particular order, document it so that you can be retrieved, used, and then taken for the next level of application. And also derived data, like processed or analyzed from the raw data, like as I told you, graphs or even the statistical data. So these are like some of the different kinds of research data wherein one needs to document properly in order to make a good output out of those documentation. Okay, fine. So what are the best practice in data documentation? So let's see like these two. I think you are able to see this picture. Nowadays we are highly advanced. We have n number of digital device wherein directly you can store the data. For example, like you can use a simple electronic lab notebook, which will enable us to capture the real-time data, edit and share, because you need not have to enter any kind of date with respect to the date available on the computer. It's going to our laptop or a notebook, it's going to capture and then record it. And also it will facilitate for the collaboration, because the people who are going to read and then analyze your data, they're going to completely trust, and then they'll come forward for collaboration. Not only that, it's going to extend to the industrial standards. So anything which is made out in the lab, so which will be taken to the industry, it should have a series of a documentation wherein it works at gram level, at higher scale, even in tons together. So these are like the documentation will really help from lab to the industry. And also like supporting attachment, as I told you, spectra, image data and file. So imagine like especially this left hand side, even I have a small research lab, organic synthetic lab. Most of the time, the student come and then they maintain a small notebook wherein they write. So usually what we follow is like we just write with respect to their name, and then record that particular experiment what has been carried out on that day. So what the student do, they keep on changing their book. If the results are not favorable, if the reaction is failed, they don't want to document and then show it to me, because they feel like only the positive result should be shown to the supervisor. That's not correct, because you need to name those experiment in a proper conventional way. here what we follow in the chemistry lab is like we give according to the code. For example, we carry out some nitration on a particular day. So we give particular, for example, like GS1 as a nitration. Even after few years, if I come back and then see like what is this GS1 stands for, the nitration. That is the way one needs to follow strictly so that it ensures clarity, uniformity across the experiments. And also over a period of time, you can create a database. So as I told you, even if some reaction fails, so you have to document and then report as it is, so that your junior or someone else in the neighboring lab wants to repeat the same kind of experiment, you can come back and then cross check this database and then conclude like this particular reaction condition and the setup is not going to work, I need to find something else. So in that way I want to save time as well as consumables, very importantly the energy, the manpower energy. And also like you can use a consistent format. There is no hard and fast rule like you need to follow. You can give project name, date, sample ID, which will help you to quickly identify, and you can search and then retrieve. For example, imagine like you are making a computational data, you have multiple files which has been named. So, but you know, like you have got a fascinating result, but exactly you don't know which particular file it has. So it was named in a very random fashion. Now, how do you retrieve those data? Because it was now not named in a proper fashion. So all that only way is like you have to open each and every file and then go for your uh, retrieve data, the data you're looking for. So if not, so overall this is going to be like time consuming.
అయ్యా నాకు పంపించే మేము చేస్తాం మేము నేర్చుకుంటాం ఎవరు పంపించి చేస్తాం లేట్ అయి కూర్చుంటారా బిఆర్ అయిపోయేటప్పటికి
కానీ బైబిల్లో కొన్ని చోట్ల నాయకత్వం కింద
అరవై 60 నేను అడుగుతాను అది 60 నువ్వు కరెక్ట్ గా కాకుండా గవర్నమెంట్ చెప్తాను 1 lakhs ఎక్కిస్తుంది
I hope this crosstalk will definitely make us not able to communicate properly. Kindly I request organizer to take care of this one.
లాస్ట్ నేను నాయకుడు
Hello.
అంటే డైరెక్ట్ గా లీడర్ అని కాదు కానీ నాయకత్వం క్రింద అనేది వర్డ్ వస్తుంది అనుకుంటా కదా బైబిల్లో. నేను అనేది ఏంటంటే అయ్యో నేను అనే వర్డ్ అది.
Hello, I request one of the organizer to help me, please.
Yes, please carry on.
I kindly request,
Yeah.
This kind happens. I really don't know whether whatever I am speaking, it's reaching you people.
Yes.
Yeah. Moving on to the next is like called as a metadata tagging, wherein you will be adding very descriptive information, the experimental type, reagent batch, and the instrument used. So this particular metadata tagging is used in industry, wherein like a product reaches the market for some other reason it fails there. So you retrieve that product and try to analyze which particular batch and who has carried out which particular time it was done. Everything can be retrieved, and then if any solution can be provided based on that, no one can come up with optimal solution. And also this will help us to get data discoverability and contextual understanding. And also this will help us to filter and also categorically deposit in a repositories, wherein basically like you are trying to generate a database. And also like this kind of data can be used or reused across a wide variety of a database used in digital platforms. This version control is very important, which will help you in making the number of edits. So the history of edit can be easily tracked down. Imagine like you are starting a research publication in a draft one. By the time it is published, it would have reached the draft stage of 10 or 12. So in between, lot of changes has happened. So if it is not named in a particular fashion, like the history of edits, so with the version number, it's going to be like extremely tedious process for you to retrieve and then come up with a final version, which is a published version. And also, like if there are multiple files, like you don't know like which one to delete. Now you feel like version 10 is the final version, so that the 1 to 9 version can be deleted, so that you can make some space available for you. So this kind of not naming them properly will lead to accidental data loss, which will also, like for example, if you are working in some banking sector or something else, like, so this might not support for the audit trials. And also, like as I told you, it will roll back to the previous version if needed, if all the versions are available, if it is properly named. So these are like the version control plays a very very important role in the documentation process. So along with this, there are a lot of data organizing tool available in the market commercially. So just a few to name them: Zotero, Mendeley, and Jupyter. Especially this Zotero and Mendeley are primarily used for the research reference and citation. Okay. Now we'll precisely come back to this research, referencing. So imagine like you have a data, you have prepared a publication. Now you'll be in a dilemma, like which particular reference style has to be put for that particular prepared research article. So before that, you need to downsize. Either you are going for the RSC publication, ACS publication, Wiley VCH, elsewhere Bentham, Taylor, and Francis, and many more to add on. So based on that, easily it is a compilation of a huge database of a reference. So just go there and then click at the required reference style. They are going to format and then give it to you in one side. Imagine your research article as a reference of 50 to 80 or even sometimes 100 plus. Manually typing them will become extremely cumbersome procedure, whereas using this kind of organization tool will make very simple. Also the citation. So how the citation, so you want to cite something, so you know like this particular journal is what you are going to look for all the content and then cite it properly. So exactly you want to go there and click it, so the citation will appear there as a reference one. And also Jupyter is a very interactive computing environment for data analyzing and coding. Imagine on the right hand side, if everything is organized properly, so you are going to get a very good result. If it is not organized, still you are going to get the result, but it is extremely cumbersome procedure, and at a particular given point of time, you yourself might not like, because it is not organized in a particular fashion. As I told you, this ethic, the word ethics, is a very, very wider term. So it is a philosophy for how we ought to live and make a responsible choice, whether it is right or wrong. So because in research, you need to have a very good ethics, because you need to follow them throughout your career time. At a given point of time, if any because of any pressure or something, if you're not following that, so whatever the research you have done till that period, it's going to be like misconduct. People are not going to believe from there afterwards. So it is like, irrespective of your situation, irrespective of your pressure, you need to strictly follow a good research ethical practice. So not only that, while training all your students, you should ensure that this is the way a research has to be conducted. This is the way the documentation has to take place. So I'd quickly emphasize like systematic study of morality. And you all know that we have spoken a lot about this values, duties, right and wrong. Rational inquiry into moral problems. So if a problem is there, how one needs to think critically and then solve the problem. So instead of that, not like picking the answer for something else and then trying to fit it here. That's not going to work. Even if it works for momentarily, no, it's going to be like caught by someone else. That's how this retraction takes place. Prescriptive and descriptive are two important, wherein one needs to analyze. And also, once you follow this a very good ethical practice, so interdisciplinary research will come into picture. So if you are in a particular domain, you are expert in only in that particular area. You have a compound. So someone else wants to take that compound for the next level application. This is possible once you follow a very good ethical practice or the good documentation. If not, nobody is coming near to you because they feel like whatever the data you are giving, although it might be genuine, so they might feel like something has been manipulated or something else is going on. So these are like one needs to strongly follow this ethical practice, especially in the research. This is for people who start their research career earlier. So imagine like as a student, so you have some data, but you are getting a pressure from your research supervisor or the project or the funding agency. So now you need to quickly write down and publish something. So now the choice comes in you like whether you need to select a good one or the bad one. Bad one always is easy and it will take to the result. Whereas good one, it takes a long time, but it remains with you forever. So it is something like you have a choice to decide whether which particular concept is right or wrong. So one needs to very, very strongly rely on this following a good ethical practice. If not, it's going to be like, over a period of time, entire research is going to be at stake. People are going to question. So recently we keep on hearing that many such, unethical practice has been followed, not only from the small research group, even the big larger research group wherein they get multi crore funding from the funding agency. In spite of that, all this kind of misconduct happens, then it's going to be like a bad remark on the entire research community originating from particular country. So what are the reasons for this unethical practice? It is purely like professional pressure. The reason behind scientific misconduct, it is like nowadays we have immense pressure. Even once you work as a assistant professor or associate or a professor or lecturer or wherever you work. So especially when you are involved in research, either you need to publish or perish. Even if you are working somewhere, so it is like how to retain your tenure job or retain your job. So for that you need to show some research activities going on and keeping up with the peer pressure. And also like when you start writing a grant for a particular agency, so by the end of that, they'll be looking for some kind of publication. What is that output has come out from the funded project? For that we need to show either in terms of publication, either in terms of a patent, in order to satisfy whatever the objective was proposed in the proposal has been achieved. And also there will be a high satisfaction if you are going to report as a first, you are the first example or first discovery of that particular research. This is like a first string shortcuts and misconduct. All this will help you, nurture the shortcuts and misconduct. So what is that? Data privacy, confidentiality, informed consent, and avoiding data fabrication, that is manipulation and falsification. So even at a given point of time, even whatever the immense pressure might be, so one needs to follow ethical practice. Never think of doing it in an unethical way. Although you might get a success, that is momentary. You never know like when it is going to tumble down. For example, you have published some 10 very good article, you can live in happiness, and then always you will not have a fear like when someone is going to retract that and then come against you. Whereas if you do the unethical, you will be like in deep trouble forever. So this retraction, you can see like India is at eighth place. India is at eighth place within the nation. So this Tamil Nadu somewhat is having at number one position. So this statistical data which is documented in 2024. So especially like I would like to tell the real split of one particular journal, why that has happened. So if you look into this particular country, China, so in 2010 there was a one particular famous journal called Journal of Metal Chemistry from RAC publication, Royal Society of Chemistry. So during that time it was only one publication. Now if you see like it is divided into three different Journal of Chemistry A, B, and C. All this happened because of this one country, China. Why? During that time, so more than 50% of the submission used to come only from this China. Among them, only a few are like highly authenticated article. Most of them are either manipulated or doctored research publication. Why this happens? Just let's go to the previous slide. Because there in China, it is told that so if you are working as a professor or something per annum, you need to produce a impact factor of around 50 plus research article. Either it can be like one big article like Lancet. I don't know how many of you know this particular journal called Lancet, wherein the impact factor of this is 205. This was something like 1 or 2 years before I saw that. Maybe now the impact factor might have gone, but publishing in that particular one Lancet, it takes your lifetime and also like 5 to 6 years. So usually like the people who are working in the medicinal field, cutting edge, towards the development of a new technology for a health sector, or a drug towards a new disease or something else. So usually get into such a big journal because that is having a very live application once it is launched in the market. So this particular country, then people started making and following unethical practice, and then started submitting a large number of articles to this. That's all, like not to go for the peer review. They had a peer pressure, and then split into three different based on the research domain. It was subjected to biology, material, as well as some physics. So that's all, like this particular journal was split because of following that unethical practice. Now, coming to another important topic is research publication. What exactly research publication? So we'll say like now we have conducted a lot of experiments, a lot of data are there. How to prepare a manuscript? So once again, like this is directly related. So you have to thoroughly study. You have to thoroughly analyze what exactly the data are, and then based on that, you need to select few journals and then start preparing your manuscript. And like once the manuscript is ready, like the content and the impact of your data. So based on that, you can select the journal. For example, like your content is good, and it can get into impact factor journal of 10. So that reason I would suggest like you better choose a impact factor journal of 8 and then submit there. There the scrutiny will be fast because your data are novel, and then easily the reviewer as well as the editor going to accept your journal, and within short span of time we are going to publish your data. On the other side, if your impact is if your data is good and the impact is around 10, if you're planning to submit in a journal of impact factor around 20 or 25, thinking that some other kind of luck is going to favor me, it is like you're going to waste your time. So after 3 or 4 months, they're going to send you back with a lot of queries wherein purely they'll tell that it is completely rejected. That's all, like while preparing the manuscript itself, you need to have a journal selection in your mind. So this peer review, most of the journal, whatever you publish, it should be peer review. So there are some paid journal wherein like they take some money like processing fees and then publish it. It's of no use. So it has to be reviewed. For example, during the introduction also it was mentioned like we keep on publishing paper in Journal of Molecular Liquids. So initially when we started, there was only like 2 reviewers for that. Even that impact factor was around 6. Now currently, I am also reviewing few of the paper. The number of reviewers for that particular Journal of Molecular Liquids is 4, from 2 to 4. That means like they want to get a peer reviewed through different number of people, so that when all the 4 says, then only they are going to accept that particular journal. So after submission, you don't know like when the reviewer is going to ask a kind of a question wherein either you have to go back and conduct some experiment, or rewrite entire script according to the requirement. So that's how like the peer review becomes very very important. So it doesn't end there. So imagine like you have published a paper in a high impact factor, it doesn't end there. Post publication metrics. So you need to make sure that this published paper is reaching wider community, and people are trying to read that and understand and trying to cite your research. That's how like post publication metrics works. So this is a schematic way. I just have shown how exactly this publication process works. So it's an idea. It's a publication is nothing but an idea of scholarly work where meticulous experiments are conducted and also drafted in the form of a manuscript by supporting with a lot of documents, and then it will be subjected for the rigorous peer review, revision, and final dissemination to the audience, which is nothing but a public, scientific reader. That's how entire publication procedure takes place. So now this is something like core of the research article. How to prepare a manuscript? What are the contents? One needs to focus on this manuscript structure. So basically, like it should have this component, which is common for most of the research article: title and abstract. It should be concise to the summary of the study. For example, sometimes people will have a very normal abstract, but the title will be like very very catchy, and then they'll be writing like some novel discovery which is going to change the entire mankind. So the title and the abstract is not correlating. You should never ever do such kind of thing. And the introduction, going to the background and research problem. So even in the introduction, it should be precise to your research finding. It is not like I need to cite somebody so that the other person is going to cite, so that both the citation will increase and will have a better index. So that kind of reference is not going to help you over a period of time. The quality of your particular research article coming out of the lab will be declined. People are not going to study your research. And methods, experimental setup and procedure, it should be transparent. Reproducibility should be more. And how you are going to interpret the data is also equally important. As I told you, by axiomatic, it's not like you are anticipating some result. Even if you get a result very close to the nearby area, it is not like you are trying to conclude and put it. So it's not exactly. So whatever the result you get, you try to present as it is. And also finally, like interpretation of findings, the conclusion part. Reference, as I told you, especially like while writing a reference or preparing manuscript, usually what we do in our research lab, we prepare a manuscript in a simple Word document, and in the reference style. So I would have downsized which particular journal we are going to publish. So we put that reference style. So sometimes I've seen most of the other research group, so they try to take the template of that particular publications, for example RSC or ACS, and then fit all those datas there and then submit. Imagine if it is rejected, you have to come back and then fit to the other publisher in their particular format. We never do that. So once it is accepted, there is something called as a production house in each publication, wherein they help us in fitting all this data into their template. So in that way, like it will become very very crucial to prepare a manuscript in a particular style itself. So data visualization. What exactly this data visualization? This is very important. So imagine like I'll show you few case study. So instead of writing a lengthy text, so if you can present in a visualization form using like appropriate charts, lines, and a label, and also use a consistent color. Usually for a scientific data, I have seen like either you use Arial font size or Times Roman. And also like color should be consistent. You cannot make a very a vulgar kind of a color system. This is not an advertisement boarding or something else. This is scientific literature wherein it conveys some strong meaning and also new finding to the entire audience. So in that way it should be like precise to the finding. It cannot have all kinds of catchy colors. For example, insert a simple graph comparing temperature versus time. So instead of reading a lengthy text of half a page, one can just look into the graph and then analyze like what is happening with respect to the temperature and time. So key publication matrix, as I told you already, like the impact factor. So depending upon your content, like where exactly your data stands. So it's also important like you publish all your research data in the high impact factor journal. Over a period of time, people are going to recognize you because you do high quality research. And also H index, by doing that your citation will improve, and also your H index, wherein if your H index is more, people are going to rate you in a different way, like is doing extremely good research. Once it is done, it has to be like put on a social media. Nowadays social media has become very important because to gain online attention. There are few known social medias like researchgate, wherein if it is a paid journal, you are not able to access it, you can directly write to the particular person through researchgate, where he or she, depending on the person, so going to share that particular published research article, wherein this kind of exchange happens through social media in a constructive way. This is another important topic, wherein plagiarism and reference. Imagine like you are writing something, your supervisor or someone had asked you to write something. This has happened in our own research lab. So initially, when one of my student, I asked her to write a supramolecular system, supramolecular chemistry, and then come up with the introduction part. She has written so nicely, like after reading that, I felt really happy that how she was able to write such a nice data. After that, when I start searching, I found that exactly the same thing which was there in the Google. So then I called and then asked like what exactly. Then she confessed that she just took there and put it here. This also happened because of peer pressure, especially like when it comes to writing a review. So review has a certain standard protocol. So wherein if you want to take some picture, some graph, some microscopic texture, so there a maximum of 3 pictures can be taken. Once again, it depends upon the journal and the editor. So with copyright permission. So you can take 3 with copyright permission, and never ever you can copy the text as it is. The image cannot be changed because it is the graph which is embedded. It is an image like GIF image, PNG, or any other kind of a format. You cannot redraw it. So for that reason, they allow 3 such picture. And also the text part, you have to thoroughly analyze and then condense it, and then overall find the gist of that particular article when you are writing a review. So that's all, like this review becomes very very important. Just plagiarism comes into picture if you don't follow that properly. So what is the overall essence of writing a review? It is like you're trying to make a particular topic available for a wider audience handy. It is not like just you are trying to take 3 pictures, write something and then publish. You have to give overall gist. I will give one more case study based on that particular review writing. Already as I told you, referencing is very very important. The citation, so you should cite the particular first generated person. If it is like something novel coming out from a particular research group, you need to cite them, not the subsequent people, so that the credit should go to the original person who has created it, not the subsequent people who has just incrementally improved the research. So there are many different tools for that. Trinity, Grammarly, Authenticate, referencing style. As I told you, these are the different journal format. Image, just to tell you, like comparison, showing the original and the plagiarized text. So nowadays, even people are trying to take the original image and then subject for some manipulation and then publish it. So people are easily catching those kind of plagiarism also. Apart from this, there are some recommended tools and repositories, which is nothing but a database archive. Some of them are commonly available. Some are paid versions, some are freely available. So these are also like a documentation wherein you can see GitHub. So a web-based platform for the version control and collaboration. There you enter all the thing, it will take care of the version, and it will say like you are in the 10th version or you are in the first version, so that you need not have to worry. Zendo and open access database for research output. Dried is another curated ligand centric database, wherein like you did not have to read the entire text in order to find the exact structure. This is a ligand centric database. Just by clicking benz, oxazole, benz, imidazole core I am looking for, so easily it will generate. It is a paid one. And open science framework OSF, so which is once again free, cross reference and ORCID. And as I told you, researchgate. So these are like commonly available, where the people, researchers usually refer and then exchange even the article, so that it reaches among the wider community, scientific community, and also you are going to get appropriate citation. Imagine like I'm looking for a particular article. I ask a particular person, the author of the person through researchgate, I get it. Obviously I'll make use of it, and then I'm going to cite this particular journal, so that his citation is also going to improve. That's all. Like this social media plays a very vital role in communication. So latex is another important tool, wherein it will help to build a very high quality uh, typesetting for a scientific documents, which is not easy when we do it manually. So it is like how we get the success. So success is something like, it's not it's not like you have something, you just compile and then finish. So steady effort leads. Making a good research article takes its own time. You have to design the experiment, you have to conduct the experiment, you have to collect the data, you have to analyze, interpret, and then go for the publication. So in that way, you should strictly follow the ethical practice. For example, a good documentation of research data, the resultant discussion becomes very very important, because how you are going to project your data, so how it is going to help the research community is very very unique. Once again, conclusion, always like conclusion should be very crisp. What exactly you have found, you are going to write that, not like you found something very small and then trying to elaborate and exaggerate in a big way. It's also not going to help. And obviously one needs to follow very good ethical standard. So in summary, following all these parameters like proper documentation, honesty, research continuity, credibility, you are going to have a very good publication which will have a wide visibility, as well as like people are going to respect that. So this is what the overall happiness you are going to get after publishing a very good article. Okay. So as I told you, like these are like some of the general things. Even you will get it, in any platform. So now precisely, I would like to emphasize on two case study. What has happened? How we have used all these parameters and implemented in order to get something out of it. So I hope if people are still listening. Yeah. Okay. Fine. So it was in the 19th century. So this particular, with respect to chemistry, since I'm in a chemistry department, I'm not sure like all the faculties and some research scholar are from chemistry are different one. Overall, I think you can understand this case study. So in the earlier, organic synthetic, technology, the synthetic procedure. So way back in 19th century, in the beginning of, mid of 18th century, this multi-component reaction began. What exactly this multi-component reaction? It means like, imagine like in order to make a molecule, we all know like the parasite molecule. It is having a three steps. How to make a paracetamol? It's quite easy. So imagine like an antiviral drug. It will have multiple steps in excess of sometimes like 29, 30, 40. That's the reason like most of the antiviral drugs are very expensive. So this particular concept came into picture called multi-component reaction. So which was first introduced by a person called Stecker, named after him, called Stecker synthesis. So wherein he thought like, why don't we use a minimum of three or four component together and then make one final compound. So that's how he made first compound, and then people started working on this kind of a system called multi-component system. Many such people named after them, and then this has become one of the common practice in making different kinds of organic molecules. We have downsized one particular reaction called Mannich reaction, because we were working similar to such kind of system. So that's what, as I tell you, documentation is very important. We just went back and then saw what exactly is Mannich reaction. Although like We have studied this Mannich reaction during our MSc time and many other places. But exactly in detail, we need to know what exactly. So this Mannich is a German chemist called Karl Ulrich Franz Mannich. So way back in 1912, he came up with a multi-component reaction, mixing three such component, and then got one compound which he basically called as base, which he named after him, called as Mannich base. So for this starting material, he started with different kinds of acidic hydrogen, aldehyde, and many component. So fundamentally, he made one particular reaction system wherein by using that, people started making different kinds of molecule useful for the drug and natural product synthesis. So we thought like why can't we introduce same multi-component reaction in liquid crystalline system, because till that date nobody has attempted to make a liquid crystalline molecule using this particular multi-component reaction. We know like every research lab now progressing towards the green synthetic technology, or a green everywhere, green everything is flourishing. So we thought like we'll use this green synthetic approach, a multi-component reaction in liquid crystal. So although like there are different kinds of core, we choose this particular core, a strong naphthalene core and a semi-flexible. So this is a cyclohexane incorporated with a 2 heteroatom. Cyclohexane incorporated with the 2 heteroatom. We all know that cyclohexane can flip between boat and chair form rapidly. So keeping that in mind, we thought like this could have a very strong impact when we make a liquid crystalline molecule. And also once this molecule is made, so we can take this for the next level application, like this will open its ring on photopolymerization, which can be used in carbon reinforced, so where it material, and also it can be used as a adhesive. So we made these two molecules, naphthalene and alkylated aniline. One more component is this formaldehyde. We have not used any kind of solvent. For that reason, we call it as a green synthesis, solvent-free condition. So two such isomers were made, and we were able to get a exciting result. As I told you, documentation, data visualization. So this is the texture, polarizing microscope texture, what we got under this crossed polarizer. So you can see like for this same data, I could have wrote like this particular compound is showing a discotic pneumatic. This is the exact phase what is used in the display technology. So we thought like instead of writing it in the form of a text, we have put entire texture as it is. So just by looking this texture, a person if he or she is working in the similar domain, one can easily make out this is a pneumatic discotic texture. And later in terms of a bar graph, we were able to convey that all these compounds are showing very good liquid crystalline property. You can see this red bars in both, especially in the cooling cycle, it is super cool. There is no crystallization even at room temperature. So another one such data is called as a DSC, wherein you can see the melting peak and then the clearing peak. In between is your discotic pneumatic. So and in the cooling one, you are not able to see any peak. That means it is super cool. Once it melts, it never turns back to the crystalline state. This is another document wherein it clearly shows a data visualization. This I think quite a few of you people know. It is a XRD, wherein the small angle and the wide angle clearly conveys that this shows a very strong liquid crystalline property. As I told you, so we have followed all this thing, ethical practice, good documentation procedure, and for that we got this recognition. So this was recognized in worldwide ChemEuropa.net news, wherein they say that towards a green chemistry, scientists developed a new process of making more eco-friendly liquid crystalline compounds. So Bangalore University, we are the first people to develop the multi-component not only in India, across the globe, in the entire liquid crystalline community. And also this particular work was highlighted in the press release of Martin Luther University, Halle, Germany. So that's all like when you follow systematically the documentation procedure, the ethical practice, complying with the plagiarism, everything falls in its place, then automatically the recognition comes in its way. In the case study 2, Okay. I think this particular case study might be interesting for all you people. We have not only like the documentation means either a newspaper or any kind of research article or anything. It can be anything. Even the video can be a documented file. The moment I show you this image, I think one thing will come to your mind is like this is a well-known documented image called Tom and Jerry. So there is another two comparison: human being and blood. These are like existing, coexistence. Just if I say human being and blood, it would be that exciting. So always like when I say two together, so you'll feel like there is some connectivity. The same way like this documented Tom and Jerry. So in coming days, it is no surprise that this kind of technology is also going to come. So because nowadays the people are so addicted, I don't know whether that's the right word to use to this system, wherein like it has become almost like inseparable. So these are like inseparable, documented images, the existing living beings, also like the mobile. So this is quite possible. Imagine like our blood is a very good, charge carrier system. So if we can somewhat isolate that and then convert with a suitable converter directly, it can be plugged into the mobile so that your mobile gets charged. This is also like quite possible. Okay. As I told you, this is one such review what we wrote, just 2 years before. Uh, Whatever the device we are seeing, so it's all made out of liquid crystalline metal. This is a case study. I'm trying to tell you how exactly we follow this documentation and other parameters. Basically, like this particular review article has in excess of close to 170 to 180 reference article, and the one common question comes into mind is like the moment you make liquid crystalline molecule, whether it will show a liquid crystalline property room temperature, it has to be room temperature, whether it can be used for the application. So what are the parameters? So what are the parameters for a molecule to get into the application level? So without good documentation, nobody can make a device. So we started digging out. This happened during Corona time because plenty of time was available. So we started digging out. Till that time, there was no such formula to make one particular compound wherein it can be taken to the application level. So then we all collected all the documents related to the research articles, related to the room temperature liquid crystal, and then downsized a few parameters which are very much essential for the device application. The first one is like room temperature. It has to be right at 25 degree. It has to be room temperature and for a wide range, so that you can make a very good device, so that it will work across a globe, right in India, across a cold country, European country, as well as in the Middle East. So if it freezes in the cold country and in the Middle East, if it vaporizes, the LC phase, so then it's of no use. So it should show a very high birefringence. So that is like high definition picture. For example, imagine like with a small amount of voltage, if your screen is showing very good brightness. So that means that once again depends upon the kind of material used there for the display system. And also it should work from minus 40 to 80, low viscosity, it should be thermally stable, and it should give a completely homogeneous mixture. And these are like different phases which can be used for the different application purpose. So you make a lot of molecules, you screen it, only few will pass through this, and then few selected will be taken to the next level application. If people might be wondering like how exactly, we all use this different kinds of, display system. So this particular display system, whatever we are using today, it is one of the serendipitous discovery which was documented way back in 1888. It was an Austrian chemist. His name is Friedrich Reinitzer. I think in the meantime, you can watch this, how exactly this display works. I would like to just tell a little history about this, documentation procedure. So this Friedrich Reinitzer, Austrian botanist, trying to find a melting point of this cholesterol benzoate. So during that time, they used to tag this compound with thermometer, and then check the same way what we use, even now also, like with paraffin liquid or silicone oil, and then Bunsen burner flame, At one particular point, if it is solid, it will convert into liquid. That particular point, we record it as a melting point. So what happened during this observation, he observed that this particular compound melted into some cloudy mass and then to the liquid state. So in between, solid and liquid, he found something like a colloidal solution. So with that observation, he wrote a clear letter to another, physicist, and then, asked like there is something else is happening. So that's how, like, slowly the evolution of liquid crystal, and further, they have made a few more molecules synthesized and then trying to characterize this liquid crystalline. So imagine like way back, 135 years ago. So this small piece of letter, which was a document, even now it is, available documentation, which was passed on to the right person for the next level, investigation. So after 135 years, we are, enjoying this display technology. So whatever the small, little research findings we do here and there. So this 10 years, 20 years is a very, very small period. It's like a very primitive age for the any kind of technology. So right from 2010 onwards, the display system grown into a bigger scale. Right now, it is a billion-dollar display technology in the global market. Because without display, none of the system works. Because the old cathode ray tube has been replaced by this TFT monitors. Now, I would like to just play this video. I hope you all can see. You'll get an idea how exactly this display works. Each pixel works in your display system. So whatever you are seeing, these are called as a liquid crystalline molecule, and this is one such pixel, in any kind of display system. This is how you can see, like, there is a black and white image forms. When you add this color filters, you'll be getting this color images. These are like each pixel, comes together. It's called millions of such pixels, and then thereby it forms a TFT monitors. So these are like all the display system works in LCD. Even it is called as LED. Still, the front shutter is LCD. Only the backlight is LED. But the same, liquid crystalline molecules are required for the display system. So where do we find this kind of a display system? So because directly we can, refer to this LCD, which offers a clear, bright visual with a low power, notepads and readers, the book readers, what we call commercially available as a Kindle. So we'll provide a sharp text and image display. So depending upon the need of a display for a particular device, they are going to make it. Desktop usually widely used for the monitors and for a high resolution display and readability. Laptop, it should be like very slim, so that compact, you can carry wherever you want, and also it should consume very less power. Television, on the other hand, supports high definition and also has a 4K display with a vibrant color, because television, you feel or prefer to watch, movies and other things, wherein this is suitable for such kind of a display. Smartphone, which is inseparable from a humankind, will once again need a display, at a very affordable, and it should show a very good brightness, for that it can be used. Medical and industrial monitors, so which need a precise imaging as well as durability. So these are like different kinds of a display system wherein people are using, but it works on the same principle as I shown. So not only that, it is restricted only to the display, and also it is extended slowly. It's coming beyond the display technology. Here you can see like, so recently people have introduced a thermal line wherein it changes the color because of optical light and little variation in the temperature. So here you can see like, the color keeps on changing, so you need not have to go remove and then put a new one of a different color. And yes, I think this explanation will tell you what exactly these LCs are. Yeah. Okay. So also not only for that cosmetic, I mean like application, also like for a smart surface science. So this is one such wherein it changes its color. The color. So slowly, this smart surface science is getting into automobile industry, wherein at one fingertip, the entire color of the automobile can be changed. Also extending for the construction area, wherein just on stamping or a little amount of a thermal energy, there will be a lot of color generated. These are like the application of a liquid crystal by a very good documentation and following all kinds of practice and parameters, one can make a very good device out of it. Okay. So it's like that we have studied how the documentation are very important, and how we can reach this finish line. It's nothing but how a research article can be published. So just to summarize, a collection of a data, so which is very important, precise to your research field, experimental research. It should be like authentic and also never try to manipulate. Follow the best practice in documentation. It need not be a standard one. Even you can develop your own indigenous one, but it should not miss any kind of data. So you need to organize in a chronological way so that you know which one is a latest one, which one is a first one. And also one has to follow very strong ethical practice. So manuscript structure, as I told you, it should be properly laid in a particular fashion, and also the title, abstract, especially the result and discussion followed by conclusion, should be highly connected to each other, so it can't be distinct from each other, so that you have a fancy title, abstract is something else, the result and discussion is quite different, and conclusion is something very different. So such kind of publication are not going to get into a big impact factor journal. So we need to incorporate more of visualization data rather than the text, because this has a more appealing in nature compared to the textual part. The research matrix is very very important, because it not only improves the citation, and also it will improve your personal glory in terms of H index. And the plagiarism and reference has to be taken care. Without that, so you can't cross over that finished line. Okay. So quickly, I like to emphasize like why this kind of research article or documentation or ethical practice are very very important. Because research and development is a very important for a developing nation. So imagine like way back in 4th century till the 18th century, India could have been called as one of the highly developed nation, but right now we are not in that state, because R&D will improve the economic growth as well as the diversification, also addresses the local challenges. For example, we have plenty of water available in the northeastern part of India, especially the Assam. During this monsoon and rainy season, the river Brahmaputra overfloods. So we need to have a certain kind of a research and development wherein terrain wise we need to geographically build such a way that it cascades and follows and then reach the place wherein there is shortage of water. So this kind of a research and development is very important for addressing local challenges, and also technologically advancement and self-reliance. So it's like you develop something, your country people use it so that the economy gets revolved around. Why most of the country wants to come and invest in India? Because of the population, more number of people. Overall, R&D is very important for the improved quality life. We all know that if you people have already stayed in some of the foreign country, the life itself there is luxury because everything is so meticulously made so that you don't feel any kind of stress. A good transportation, a good health system, a good education, a good water source, a good kind of whatever depends upon the geographical condition, the food, and then the culture. That's why like they feel always like they have a better life than us. Having said all these things, what are the challenges of our R&D in the developing nation? Always like there is a limited resource and funding. Even when you write a proposal and subject or submit to a funding agency, you ask for certain lakhs, like some 10 lakhs, usually they'll be giving some 7 lakhs or 8 lakhs. They're also like, there is a limited source, whatever the objectives you have, proposed there, still you need to fulfill that with the downsized amount. That's all like, the funding comes or becomes a very, very crucial. Human capital deficiency, sometimes they give the fund, but there is no fund for the manpower. In the fund, apart from non-recurring equipment, you'll find manpower will take large amount of money because it is considered that manpower is ultimate. Wherein, if you have a very good manpower and follow all these practice parameters, so one can come up with a exciting result. Weak infrastructure. So very often we keep on buying equipment after the equipment. Somebody buys equipment, puts in some place, it is not used, it goes back. So we need to have a one common a facility wherein still it is not happening. Even in the Premier Research Institute, everyone has their own research lab. They need to have their own research equipment. So policy and institutional gap, market and demand, and of course like ethical consideration. Okay. So what strategy one can implement in the R&D for a developing nation? So first thing, it is like the responsibility of the government to increase the investment and funding, and also develop a human capital. So quickly, we need to have a very stable, robust infrastructure, which will help to raise an important innovation economy, and also like strategic technology for the transfer and adaptation. You imagine like you have a technology, how you need to adapt in a real system. For that you need to have a very good implementation process. So and also like it should always promote the demand. So whatever the existing, we don't have a very good transportation here because we spend a lot of time wasting in the traffic. So we need to have a very good transportation system. So it should be like based on the local problem driven application. That's so like a country can change its tack from developing nation to the developed nation. Okay, how do we call or how do we rate like a developed nation? Of course, apart from GDP and economic growth, basically like these three component a country should have in order to have a very good developed tag. So first is water. Once water is so most of the food problem or the agriculture sector is taken care. Electricity, in order to manage that, you need to have electricity and good transportation. If these three are there, most of the other problem can be solved through this three surplus availability. And this was not known to me like career advancement. So just once you follow all these parameters, irrespective whether it's in research or in industry, you can reach the top position. It is like you need to have a continuous learning and skill development. It's not like whatever you have learned at 10 years or 20 years before, you can't say that that is the ultimate. I don't want to study anything new. That's not going to help. Network and mentorship, this is very, very important nowadays, because if you don't open up yourself, people are not going to recognize you, and without that you will be not getting the credibility. And you need to be extremely proactive and also like your value should be demonstrated. You need to demonstrate so that people can recognize you. And for each and every experiment or even in the industry, you need to have a strategic planning as well as goal setting. So whatever you do, it should be visible. For example, you are doing a research, so it should be visible. So you are doing something else, it should be like known to the a wide range of people. Feedback and adaptability. For example, if you get some kind of feedback, if it is genuine, if it is negative also, like you need to take that feedback positively and then adapt yourself so that you can remove those limitations from your existing negative feedbacks. Leadership and collaboration, very very important. If you are a good leader, obviously I want to follow all this thing parameter, then only like you'll be a very good collaborator. Also, like if there is a problem, you need to have a solution for that in a innovation way. So in a not like old conventional which might not work for the present generation, you need to come up with a very simple and a quick solution so that people readily accept without a second thought. And personal branding, so this is very very important. You write a research article, you construct a graph or make a statistical data or anything, even a simple covering letter. The way you write it should be quite visible that one should tell that this was written by so and so, this was written by X person, this was written by Y person. To that extent, you should write so that you stand entirely unique among all the others. So that's called as personal branding. So, in final conclusion, I think we have something close to some 9-10 minutes. So, in final conclusion, so after following all this, parameters, so basically, like since we are in research arena, I thought like we should focus more on this only. So, rigorous documentation is supreme. Without documentation, you can't even start your process. Publication demands precision and ethics. You need to know what exactly you are doing, and you need to follow all ethical practice. So also like very important for this, when you are taking a complex problem, how you are going to solve that. So this is only possible once you have a prior knowledge. Without that, it's going to be like of no use. Either it will be a kind of incremental research, you cannot have any kind of substantial new or a novel data, so that it's going to help for the further generation to take on. And integrity underpins the credibility. Always, as I told you, research should be like extremely conducted at its honesty. So that means what? For example, just to cover up, you might give some kind of manipulated result to the supervisor, or with that only like you are going to publish. That's not going to help you for a longer time. So it will be caught one particular day. For that, research is something like you are trying to find whatever the data you get, you just publish as it is. So that might be useful, may not be useful. Just the incremental, it has its own uniqueness. It adds its own value. So based on that, we just leave it at that stage for a wider audience so that they conclude what exactly this publication speaks about. So that should be the overall content of your publication process. So we have come to the last part. It's like what are the parameters you need to follow in order to reach this success in the career. Either it could be academic one or industrial one, or wherever you go, you need to have a certain kind of uh, documentation procedure. So either you are doing it manually or doing it electronically, it has to be there. If not, if it is not organized in a particular fashion, in a disciplined way, it's going to be like extremely tedious to retrieve, follow, and then use it for the next one. So during your journey, you'll be having a lot of other hindrance. So somebody might tell like just copy and paste, just you'll reach your success point very quick. So it's not going to help you for a longer run. So always slow and steady wins the race. Of course, like now you can't be that slow also. You need to go with the pace. And also obviously like this ethics, at any cost you should never compromise on this. You should follow very very strong ethics. By doing this, so you're not only learning for yourself, also training the next level generation, the student. Either it could be a UG student, PG student, research scholars, and postdocs. So even they need to have that. Unethical is something which they don't know. Ethics is the only thing which will take to the very good success in their life. So imagine a person is spending over a period of 30 years. If he follows a good ethical practice, by the end of that term, he can come up with some exciting, research or something else. If a person is taking the other path, so he or she will be not even recognized even after 6 months, 3 months of that particular department. This is the difference between long run and short term success or happiness. So with this, I think I'll just wind up and then thank all you people for your kind attention. I feel like if any question is there, I can answer you.
Any questions? I request all the participants to ask any questions.
Thank you very much, sir, for clearly distinguishing what reputed and what you call unethical generals. So we are very grateful for your insights to unethical publication practice and risk of publications in low quality journals. Thank you very much, sir.
Yeah.
Good afternoon to one and all. On behalf of all the participants, I sincerely thank Dr. G. Shankar for his insightful session on publication ethics, the publishing process, and career advancement. Your valuable knowledge and guidance have greatly enriched this faculty development program. We appreciate your time and effort in sharing your expertise with us. Thank you once again, sir. I now request all our participants to kindly fill the feedback. The link will be posted in the chat box.
Yeah. I once again thank entire organizing committee as well as the AV College of Arts and Science for considering me to give this particular topic. Although we have very little knowledge on this one, but more or less directly or indirectly we follow certain parameters in our day-to-day activity, and that's how we were able to make few impact with whatever publication we have. Yeah. I would be happy if any questions is posted to me or in any way so that can be answered. Yeah.
Request all the participants to fill the feedback. The link is posted in the chat box. Any questions? Request all the participants to fill the feedback.
this is a gently reminder regarding day 2 of this 5 days FDP, which was originally scheduled for 29/7/2025. So it was postponed to the second, that is tomorrow, due to technical reason. I request all the participants to attend the session tomorrow, which will also make the final day of FDP.
Yeah. Is there anything else, or can I leave now?
Yes, yes, sir. Thank you very much, sir.
Yeah, fine. Okay, thank you once again. Like,
Thank
yeah, nice talking to all of you people.